All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So more moment of inertia. This time we're saying let's find the moment of inertia about our x-axis and our centroidal x-axis. So our x-axis is given. Let's come in and estimate before we do anything else. Just an approximate location for our x prime axis. It helps us vision out what do I need to find as I go through this. So I'm going to guess that it is somewhere, maybe it's right around here. Again, this is a total guess at this point. It doesn't really matter what I say. As I come in and I look for this, I'm going to need to figure out where is that axis at. To do that, that's going to be a y distance. From the x-axis up, I'm going to need to find y bar. So we'll fill in, I already set up the table for it, but we'll fill in our table to help us follow through what we're doing there. I might also know if I'm doing moment of inertia, I'm almost guaranteed to have to use the parallel axis theorem. Our parallel axis theorem tells us that the moment of inertia about any axis I want to take a look at, that could be the x-axis, that could be the x prime axis, anything I want to do, is the moment of inertia about the centroid of a shape. That's our I bar term, and our tables down below, that'd be our Ix, Iy prime type things, plus the distance in between those two axes squared times our area. So that's really where we're going with this. So let's come in and start filling in our table. Technically, I could get Ix without filling in this table. We're going to see that it actually makes it a little bit easier. If I'm having to do it anyway, let's just make the table first. So for my rectangle, I need to figure out for every piece. If I'm looking, we'll write one more equation down. My y bar should be the sum of our y tilde a divided by our total sum of our area. So we're filling in this equation into our table. So I need an area for everything. What's my x tilde? That should be a y tilde, not an x tilde. Let's go ahead and tweak that really quick. Y tilde a. This is why you don't copy and paste things. Y tilde a, or in y tilde a and y tilde. So we're actually getting here, not x tildes. So just make that correction. We can see that looking at this. I need a y distance for y bar, so I need y tilde distances. I'm looking at x-axis in here. It's a common mistake. So just fix it before you go through everything. But we can come in and get everything set up. I need for my rectangle then, what's the area of it? So I can say that rectangle is 4 inches wide, 2 plus 6, 8 inches tall. So 4 times 8 is 32. For the quarter circle, my area should be pi r squared divided by 4, because it's a quarter of a circle. So my radius here, we're not directly told radius, but I know my distance from the center of this circle up to the top of it is 6 inches. That, by definition, is the radius. So my radius here is 6. So I can say my area is pi times 6 squared over 4. Or this area is 28.27 inches squared. And then finally my triangle. Area of a triangle is 1/2 base times height. 1/2. My base in this triangle is 6 inches. My height is 6. 1/2 6 times 6 is going to get me 18. And in my equation, I do have a sum of my area. So let's add this all up. 32 plus 28.27 plus 18 is going to get us 78.27, which would be our first column in here. The next one is, what's my y distances? I'm going to measure all of these from the x-axis up in the y direction to the centroid of each piece. So for the rectangle, our first one, it starts on the y-axis. So I can just directly say my y tilde is half the height in here. 2 plus 8 divided by 2, 8 halves. 2 plus 6 divided by 2. 2 plus 6 is 8 divided by 2. 8 halves is 4. For the quarter circle, I need to first get where it starts. My centroid formula for a quarter circle measures from the flat side up in the y direction, 4r over 3 pi. So I need to get to the flat side. So go up 2 plus 6, 8. And then an additional 4 times the radius of 6 over 3 pi. Or this is 10.55. 10.55. And then finally for the triangle in here, I again need to get up to the beginning of the triangle. That 90-degree angle in the corner is where we measure centroids from. We probably know that from distributed load talks. But we can see it in our picture too. From the 90-degree corner, I go up y bar, the height over 3. Where that's going to get me get to the beginning of the triangle, plus the height, 6 divided by 3, plus 6/3. This is 4. And I never add up my tilde distances. There's no sum of my y tilde in here. There is a sum of our y tilde a, so we'll add up this last one. But to get y tilde a, I just multiply these two columns together. 32 times 4 is 128. My next one, 28.27 times 10.55 is 298.19. 298.19. My third one, 18 times 4, is going to get me 72. And summing that up, 128 plus 298.19 plus 72, I'll get 498.19. 498.19. Which is everything I need to get centroid. I have my total y tilde a, my total area. Let's come off to the side and get my y bar calculation. Y bar is my total y tilde a, 498.19, divided by my total area, 78.27. 78.27. Or calculating that out, y bar is 6.36 inches. 6.36 inches. From there, I can come in and start trying to do centroid for everything. So no matter what I'm doing, all of these were positive. I'm just going to add them together. So my total moment of inertia is 1 plus 2 plus 3. Whether I'm doing that for my IX, it'd be IX 1 plus 2 plus 3. Or my centroidal one, 1 plus IX 1 prime plus IX 2 prime, IX 3 prime. Whatever order I want to put them in. So let's come in and tackle that. So for our IX, our moment of inertia about the x-axis is going to get us we have to use the parallel axis theorem here, is our moment of inertia about the centroid of our object. So if we start with the rectangle, that's going to get us our base is 4, our equation here, Ix prime is base times height cubed over 12. That is I bar in this. So base 4 times height 8 cubed over 12. Plus, what's my distance between my centroid of shape 1, the rectangle, and the x-axis, my axis of interest in here. I actually calculated that out already. That is, for Ix, that's just my y tilde. So I can say plus y tilde squared plus 4 squared times the area. And I found the area already too. It's 32. And that'd be our first one. Let's get our triangle in for our next one. So plus, for the, we should go the same order as our table just to make it easier to follow. For the quarter circle, plus, what do I have here? My equation is about the flat side of a quarter circle. I would have pi 16ths minus 4 over 9 pi, r to the 4th. So times pi 16ths minus 4 over 9 pi times the radius, 6 to the 4th. I'm just giving me my I bar term in here. Again, pull that from the table. Plus d squared a. So plus my distance from the centroid of that quarter circle to my axis of interest, my x-axis, is going to be 10.55. So times 10.55, or plus 10.55 squared times the area, 28.27. Times 28.27. And then finally, I have one last piece I need to add in here. Let's get that triangle in. So plus, for the triangle, I have my Ix prime in here, moment of inertia about the centroid of a triangle, is base times height cubed over 36. So we can get that one in there. Base is 6 times my height, also 6 cubed over 36. plus, what's my distance from the centroid of my shape, I bar, that was at 4, to the centroid, or my axis of interest, to the x-axis. Really just what's my y tilde distance for this. So plus 4 squared times the area. 4 squared times my area was 18. Is going to get me, when I add all of that up, to my total moment of inertia, Ix, is going to get us to 4,226.69. 4222.69 inches to the fourth, which is our first answer for that problem. We can get our next one, getting Ix prime. It's really going to be a similar process. That first half of everything isn't going to change in here. Our moment of inertia, the centroid of the entire piece, of the entire shape, is the exact same equation. Our area isn't changing as we go to Ix prime. All that's going to change in here is our d distance in this. Will be different for all three of these. Also, anytime we do moment of inertia, the smallest moment of inertia we get for any axis direction is going to be through the centroid. So Ix prime will always be less than Ix for any other axis we look at in here. So if we get a bigger number, there should be a red flag that something's wrong. But I can come in and get Ix prime. Ix prime should be, again, we're now saying what our moment of inertia about that centroidal x prime axis is our distance, or our moment of inertia by the centroid of a piece plus the distance between the centroid of an individual piece and the centroid of the whole shape squared times our area. That distance would just be y bar minus y tilde. We'll get us there every time if we're doing a centroidal calculation in here. So getting that centroid figured out helped us because we just pulled y tilde out and the area out. Now it's helping us because we're just changing y tilde to y bar minus y tilde, or y tilde minus y bar. Either way, it really gets us to that same point. So this is going to get us, for shape 1, 4 times 8 cubed over 12. Again, that part's the same. Plus our d distance is going to change. Y bar minus y tilde. So 6.36 minus 4 will be the distance between our x prime axis and the centroid of an individual piece. We square that and multiply by the area, which is still 32. And that's my first one. We'll add into that same approach for the second one. So plus, same beginning point. Our I bar is still pi 16ths. I need a bracket or a parenthesis in this. Plus pi 16ths minus 4 over 9 pi times our radius, 6 to the fourth. Plus, again, we're using y bar minus y tilde. I put this one in as y tilde minus y bar. That way, in my calculator, it shows up as a positive. Technically, it makes 0 difference, but we've all run into sign errors before. So let's trick our calculator into just giving us the positive and eliminate that potential. So times y tilde 10.55 minus y bar 6.36 squared times our area 28.27. And then we have one last, we need to get our the triangle in here. So plus, again, our beginning's the same. 6 times 6 cubed over 36. Plus, our distance squared is no longer 4. We want to do y bar minus y tilde. 6.36 minus 4 squared times the area is still 18. Adding all of that up here, we're going to get that my Ix prime is equal to 1051.82 inches to the fourth. Or again, we are getting a smaller moment of inertia. At least logically, our answer is on the right track here. We might have made a calculation mistake, but ballpark, we can say, hey, it's a good sign we're getting a smaller number than Ix. But hopefully this is a useful video for us. If it was, hit those like and subscribe buttons. Stick around, watch some more videos. Let's get you in with JJ.